I am taking one question and I told you how to convert degrees into radians. So question number one, second part. I'm taking second part. That is, you have given minus 47 degree and 30 minutes. We have to convert into radians. So before converting, it should be in the degrees only. We cannot directly convert minutes. Minutes should be converted into degree and then we can convert into radians. Okay. So for that, the easiest way is first you have to take out negative sign common. Okay. Now you have 47 degree and 30 minutes. So 30 minutes should be converted into degrees. And you know that 1 degree is equal to 60 minutes. But here you are converting minute into degree. So 1 minute will be equal to 1 by 60 degree. So that means you have to divide by 60 degree. You divide by 60. Yes, 47.5 or we will write in fraction actually. So that will become easy for calculation. Hmm. Otherwise, we can do decimal also. Yeah, no problem. So 47 degree, 30 degree means half, 47.5 you can write directly, that is also possible. So 47 plus, that means 47 plus 30 minutes, the 30 minutes divided by 60, only this one, this will become whole degree now. Now it is converted into degree. So now we get 47 plus 3 ones are 3, 3 2 are 6, 1 by 2 degree, and 47 twos are 94 plus 1, 95, 95 by 2 degree. And now, as I told you, you should remember the relation. hmm, One, we are converting degrees. So here left side we will write degrees. So 180 degree is equal to 5 radians. 180 degree is equal to 5 radians. So 1 degree will be equal to 5 by 180 radians. And we have to convert minus 95 by 2 degree. So minus 95 by 2 degree will be equal to minus 95 by 2 into 5 by 180 radians. And this you can solve. It is divisible by 5, 5, and the, okay, I will solve here 2 into 180 degrees. So it is divisible by 5, 5 is a 15, 5 6 is a 30, and 5 1 is a 5, 5 9 is a 45, so 36 2 is a 72. So 19.5 by 72 radian. That's enough radian. So like this, we can convert any degree into radian. So other questions you can solve. That is for your homework. Okay. Next, now we will convert radians into degrees. So second part, we have the second question. There we have to convert radians into degrees. Second question. Find the degree measure of the corresponding radian, and pi is equal to 22 by 7. It is already given in the question, but it is not necessary that they will give pi, but here it is given. So Here we have to convert radians into degrees. So there are two types of questions. One question is having these two last two questions are having pi and they are not having pi. So we can take one question which is not having pi, another question which is having pi. Radians can also be written as suppose 5 radians, pi f, right? So we can write 5c also. So okay, we can take -4. Second question, -4 radians, which is given in radians, correct? Will be converted into degrees. -4 radians we have to convert into degrees. So as I told you, we can start from, we know that pi radians is equal to 180 degrees, because radians are going to be converted into degrees. So we will write left side radians, pi radian is equal to 180 degree. So therefore 1 radian will be equal to 180 by pi degrees. Degrees we cannot write in pi. Pi we have to remove. That's why it is given value of pi. Now we have to convert -4 radians. So therefore -4 radians will be equal to, radians we can write like 4 -4c also. Okay. So that will be equal to 4 minus 4 into 180 upon pi degrees. But here pi is there, we cannot write the pi. Okay, we cannot write the pi. So pi should be converted into 22 by 7. So we can write 22 and here we can write 7 degrees. Now, if you check this multiplication, whole multiplication, it is divisible by 2 first. 2 ones are 2, 2 ones are 2, 2 twos are 4, and then you multiply 7 to the 14 into 18. You will get 2520 divided by 11 degrees. Got it? Multiply 180 into 14, you will get this number. You can check. Then check 14 into 180. So 2520. How will you convert into minutes and degrees? Then you will divide 2520 divided by 11. 2520. I told you can convert into decimal, that becomes easy. So divided by 11. Yes. So 229.09. Correct. So we are getting 229.09 degrees. Okay. Or we can take one more decimal place. Okay, no issue. So now we have to convert -229 degree is as it is plus 0.09 degree. This 0.09 degree, 0.09 first multiply with, because 1 degree is equal to 60 minutes. So multiply with 60, you will get 6 9 the 54. So find 0, 9 multiply with 60. So 5.4. What will you get? 5.4. So 5 minutes, that means you got 5 minutes. So this will become minus 229 degrees 5 minutes. 5 minutes. And then zero point 0.4 is also left. So 0.4 again multiply with 60 because 1 minute is equal to 60 seconds. So again multiply by 66 for the 24 and decimal, and that will be 24 only. So we get 24 seconds. So if you find the answer, you will find 27. Why? Because they have not converted into decimal part. They have taken into the fraction and then find out converted directly into the degrees and minutes. But this is the easy one. So that doesn't matter if you are having a small difference. So this is your approximate conversion of minus 4 radians into degrees. 229 degrees, 5 minutes and 24 seconds. So when pi is not there, we have to substitute the pi. When pi is there, it becomes easy because pi will cancel and the calculation will become very easy. 5 pi by 3. Okay. Third question. 5 pi by 3. We have to convert 5 pi by 3 radians. We can also write 5 pi by 3 and small c, that means radians. Convert into degrees. So as you know that radians, pi radians is equal to 180 degree. So 1 radian 180 by this, and 5 pi by 3 radians will be equal to 5 pi by 3 into 180 upon pi degrees, or you can use the simple. Then pi and pi will cancel. So we get 5 by 3 into 180 degrees. That means 3 6 are 18, 60, and 5 6 are 30, so 300 degrees. So it becomes very easy to convert whenever we have given the pi. Okay. Now we have question number 3, exercise 3.1. This question number 3, 4, 5, 6, 7. All are the applications. Okay. So we will take these questions. These are the applications. Word problems. You can say applications, the word problems, whatever. The problem is here a wheel makes 360 revolutions in 1 minute. A wheel makes 360 revolutions in 1 minute. Through how much radians does it move in 1 second? In 1 second. We have to find in 1 second what angle it will make in radians. 360 revolutions in 1 minute. So in what we have given in 1 minute, this wheel is rotating, and in 1 minute, the number of revolutions are 360. Number of revolutions are 360. Correct? It is given. 1 minute means 60 seconds. That means we can say that is in 60 seconds. In 60 seconds, the number of revolutions are same. 1 minute is equal to 360. 1 minute is equal to 60 seconds. That's why 360 revolutions. So in 1 second, how much revolutions it will take? We have to find in 1 second how much angle it will take. So first we will take how many revolutions it can make in 1 second. Because in one revolution, you know that 360 degree. In one revolution, anything is taking one revolution. We have seen that this one revolution is, it is starting from here, ending this point. This is 360 degree always in degrees. But in degrees, we know 360 degree or is equal to actually 2 pi radius. Because 180 is equal to, as we know, 180 is equal to pi, multiply both sides 2, 360 will be 2 pi. Hmm? So in 1 second, in 1 second, in 1 second, it will make 360 by 650 revolutions. That is 6 revolutions. How many revolutions? 6 revolutions. And each revolution has 2 pi radian. If radian, you can consider radian, you can write in degrees and then you can convert into radians. So it is easy because here one revolution, it is full revolution. So one revolution is 2 pi, making 2 pi angle in one revolution. Okay. So we will write in revolution, in one revolution makes it makes 2 pi radian. 2 pi radian. So in 6 revolutions, it will make 6 into 2 pi. That's it. 6 to the 12. 12 pi radian. So it is not a difficult question. So directly we are converting because the revolutions are in whole numbers. Okay. Next. Next question is find the degree measure of an angle subtended. This is very important. We have not done this type of question when length of arc and angles are given. How to do that one? So see here, find the degree measure of the angle subtended at the center of radius 100 centimeter and length of arc. So we have to find the degree measure. See, whenever we have given a radius r. Here we have given radius r. Radius is equal to 100 centimeters, correct? And length of arc L is equal to 22 centimeters. Then angle. So remember one thing, because angle is equal to arc upon radius. You know that angle is equal to, we have seen the arc upon radius. That means we can say theta is equal to L upon R. So, but you remember always that when when R and L are given in centimeters, both are in centimeter, both are in meter, then theta will be in radians, not in degree. Theta will be in radians. So first we will get radians. So theta, first you can put in this formula, put the values of theta, L and R. So L is how much? 22. R is 100. So 2 ones are 2, 2 fives are 10. 11 by 50 radians. This is the radian. This much angle will be subtended by the arc of length 22 centimeter in the circle of radius 100 centimeters. This radian we have to, but they have, if they would have asked about the radian, this will be the answer. But they asked to convert into degrees. Okay, so we have to convert into degrees. So radian into degrees. So pi radian is equal to 180 degrees. So 180 by pi. So 11 by 50 radian will be converted into degrees. So 11 by 50 into 180 by pi degrees. Now it will convert into degrees and substitute the value of pi 11 by 50 into 180 upon 22 by 7. 7 will come up degrees. So 11, 1 the 11, 11 2 the 22. And this 0 and 0 will cancel. Okay, 5 to the 10. So 18 into 7, 7 8 the 56, 5, 7 1 the 7, 126 divided by 5 to the 10. So 12.6, 12.6 degrees. The answer is 12.6 degrees, and 0.6 into 60, you get 36. So you can write 12 degrees and 36 minutes. We should write in degrees and minutes. Huh? Answer should be written in degrees and minutes. If degrees and minutes are given and we have to convert into radians, so that minutes should be converted into degrees and then into radians. So this only you have to remember. Okay, got it? This is a circle of diameter 40 centimeters and a length of chord 20 centimeters. So you have seen here that 40 centimeters diameter, not the radius, correct? 40 centimeter is the diameter. So diameter is 40 centimeters, then radius will be 20 centimeters. And length of chord is also given. Length of one chord is given. Length of chord is equal to 20 centimeters. Okay. So if I draw the length of arc, length of chord, this is 20 centimeters. Then radius is also 20 centimeters. So this will be also 20 centimeters. This will be also 20 centimeters. As we have given the radius also 20 centimeters. You can see this is also 20 centimeters. This is also 20 centimeters. And length of chord AB is also 20 centimeters. So this is an equilateral triangle. That's why they have not given the angle. In an equilateral triangle, the angle is 60 degree. So therefore, here theta is equal to how much we got? 60 degree. Theta is equal to 60 degree. Theta is equal to 60 degrees. And radius is given 20 centimeters. We have to find AB, this length. Length of arc is this one. We have to find the length of this arc, then find the length of the minor arc. This will be the minor arc only. Obviously, this will be the minor arc, means this length we have to find. As I told you, when we are using this theta is equal to L upon R, we know that theta is equal to L upon R. So what we have to find? L. So L will be equal to theta into R. But theta should be in radians. Theta should be in radians, must be in radians. Correct? So we have to convert into radians. In order to convert 60° into radians, so first you can convert separately, or you can write 60° into radians. You have to convert pi by 180. This will convert into radians into radius 20 centimeters. So answer will be in centimeters. Here we are writing the length. We can use the pi, or we can leave the pi, or we can put the value. It is up to us. So 6 3 is 18. So we got 25 by 3 centimeters is the length of an arc. That's it. You can leave it here. Huh? Sixth question, we have given the in two circles arc of the same length. Means there are two circles. First circle arc of the same length. Means first circle will have length of arc, second also. But first has angle 60°, second has angle, first one, second one has angle 75°. At the center, find the ratio of their radii. So length is equal to radius is equal to what? L upon theta 1. Theta is equal to L upon R. So R is equal to L upon theta. So length L upon 60°. This will be R1, and R2 will be equal to L upon 75°. And then you can find their ratios. So R1 upon R2, find the ratios. R1 upon R2 will be equal to L by 60 divided by L by 75. So this will become L by 60 into 75 by L. So L and L will cancel. We get 4 by 5 and solve this 4 by 5 ratio. Similarly, here we have given the three questions. One is the find the angle in radians and a pendulum swings. Pendulum, you know that pendulum. This is a suppose rigid support, and that pendulum is swing if its length is this, and describe an arc. The pendulum, when it is making swinging, so then it will go like this here, and it can go like this here. So we can say that this will be the circular path of the pendulum, and this is 75 centimeters length of arc, and describe an arc. First question, if we take first question, this is 10 centimeter. Find the angle. This angle we have to find. So angle is equal to arc upon radius. So theta is equal to arc 10 upon 75. That is 2 by 15 radians. We get in the radians. So answer should be written in radians like this. We can do the second and third. So that's it. We have finished this exercise. So next time we will start very important part of the trigonometry. Okay. So this is different part that we have done. This is based on the angles, and next we have the trigonometrical ratios.